Hello, my dear students. This is Rima. So today we will be starting a very important topic, that is from the motion chapter of class 9. That is the graphical representation of motion. So how we will represent the motion of an object in using graphs. Okay. And those who are watching my video without subscribing, please do subscribe to my channel, and also don't forget to click the bell icon so that you will get notified of my future videos. Okay, so let's get started of this topic. So this is graphs of motion. Okay, you know what is a graph, right? For representing what? Any physical quantity. Any physical quantities we can, any two physical quantities we can represent using a graph. And we'll get, we have seen certain graphs in your maths subject. So this is, in physics also you have certain graphs, that is especially in motion. So the first one is the distance time graph, that is a dt graph. Okay. So I'll show how will be the distance time graph will be. So you know what is, this is the y-axis and this is the x-axis, right? So okay, this is our x-axis and this is a y-axis. So in distance time graph, usually time we will represent in the x-axis and distance will be representing in the y-axis. See, for example, your car is traveling certain distance. Okay, so this is my time. Okay, 0, 5, 10, 15. I'm taking equal intervals. Okay, and here I'm saying what? 5, 10, 15, 20, like that. So my car is traveling and it covered 5 kilometer. Okay, 5 kilometer in the first 5 minutes. Okay, so it covered 5 kilometer in the first 5 minutes, and in the next 5 minutes, that is in the first 10 minutes, it covered another 5 kilometer. So it will be what? It will be somewhere here. Okay. So so when I draw my graph, it will be like this. Okay, now it is not showing a straight line because I'm drawing it free-handedly. So if you use your ruler and all, then you will get a straight line. So during a uniform motion, okay, in a when an object is moving in a uniform speed. Okay, so when an object is moving in a uniform speed, that is what uniform speed means, what? Covering equal distance in equal in equal interval of time. So here it is 5 minutes, here also it is 5 minutes, here is 5 minutes. So 5 minutes it's covering 5 kilometer. So the next 5 minutes is covering another 5 kilometer. So the graph of distance time graph of an object moving with uniform speed will be a straight line. So this is the dt graph of object moving in uniform speed. So what will be the dt graph of an object moving with the non-uniform speed? See, for example, okay, so here this will be my time and this will be my distance. Okay, so here also 5, 10, 15, like that. So in the first 5 seconds, my object moved, say, 1 kilometer. Okay, and in the next 10 seconds, my object moved how much? Okay, 5 kilometer. In the next 15 minutes, my object moved how much? If say 15 kilometers. It will be not in a straight line. It will be a curved line. Okay, so if you see a distance time graph like this, which is a curved line, that is of an object moving in non-uniform speed. This is the dt graph of object moving in non-uniform speed. So again, what will be the dt graph of an object which is at rest? Okay, so what it will be look like? Here also 5, 10, 15. This will be time, and this will be my distance. Okay, distance we are denoting by s. Okay, so here also 5, 10, 15. So what it is saying, if my graph is like this, my car is at the same distance. Okay, so it will be a straight line parallel to the time axis. So if you see such kind of graph, what it denotes, my object is at rest. So see here, that is dt graph of an object moving with uniform speed. Uniform speed will be a straight line which is inclined to the time axis. A straight line inclined to the time axis. So actually the nature of the graph is studied with the help of the slope. Okay, see, you can see the straight line is inclined to the x-axis at a certain angle. Say this is theta. Okay, at an angle theta, this slope is inclined to the time axis. So what does the slope tells of a dt graph? The slope of a dt graph should tell something, no? Actually, the slope of the dt graph is giving us speed. Okay, slope is equal to speed of a dt graph. So here, how we'll find the slope? You have not learned this. Actually, this is trigonometry. Okay, but I'll tell. Okay, slope means what? This. Okay, what is this? This is the opposite side of this angle. So the opposite side divided by adjacent side. So for this if my object has traveled this distance, for this distance, what will be the slope? Slope means what? This opposite by adjacent side. Opposite side means what? This is, for example, my triangle will be A, B, C. So the slope here, slope is BC by what? AC. BC by AC means what? BC is what? Distance. See, BC is what will be equal to this length, no? So this is 10. Okay, 10 by what is AC? AC is gives my time. So 10 by 10. So what it is? 1. Okay, so that is what speed will be 1. Okay, if this and this will be what is that? Meter per second. So this is in meter and time is in seconds. My slope will be what? 10 meter divided by 10 seconds. That is what? 1 meter per second. That is my speed here. So the slope of a dt graph will give what? Speed. Slope of a dt graph is going to give a speed. Okay, so how we'll get the speed? Opposite by adjacent. So opposite side is parallel to this y-axis, no? So we'll get the distance of using the y-axis, and then divided by the x-axis we'll get the time. So distance divided by speed, time is speed. So the slope of dt graph is giving us the speed. Okay, the second graph of the motion chapter is velocity time graph. Okay, velocity time graph, what it will show? So in the x-axis we will show the time. Okay, the x-axis and the y-axis. So time will be in the x-axis and velocity will be in the y-axis. So here also we can see how our graph will look like. 0, 1, 2, 3, 4, 10, 30. Okay, so now during my first hour, my car is at 30 km/h, and during my third hour my car is at 30 km/h. My fourth hour my car is at 30 km/h. So how my graph will be? My graph will be a straight line which is parallel to the time axis. Okay, a straight line which is parallel to the time axis. So what it is interpreting? If the object moves at uniform velocity, the height of the velocity time graph will not change with time. Okay, so we get a straight line. So here when the object is moving with uniform velocity, the object is not changing the velocity. So here what is the case? Object moving with uniform velocity. Okay, so here also we can find something. Okay, so velocity and time gives what? Velocity into time is what? That is displacement. So see, we need to calculate the displacement. Okay, displacement between what? Between the time, the first hour and the third hour. Okay, so we have what? We have a rectangle is formed here, no? A, B, C, D. We have a rectangle. So the area under, okay, the area under the velocity time graph will give what? Will give the displacement. See how we know we have to calculate this area. How will calculate this area? AB into BC. It's a rectangle, no? So length into breadth. So what is BC here? BC here is 30. That is speed, velocity. 30 into AB is what? The time interval. T1, T2 minus T1. 3 minus 1, 2. So here what? The area under velocity time graph gives what? Displacement. How? The area of rectangle ABCD, which is equal to AB into BC, which is what? AB means what? AB is a time. Okay, that is what? Time into BC is what? BC gives a velocity. So displacement we'll get. Okay, so the area under the velocity time graph gives us the displacement. And if you see a velocity time graph which is a straight line parallel to the time axis, what it interprets? It interprets with the increase in time, our velocity is not changing. So we have a uniform velocity here. So that's why the graph is parallel to the time axis, and we get the displacement how? By calculating the area under the velocity time graph. Okay. So now what will happen to our velocity time graph if our object is increasing the velocity uniformly with the time? Say in 1 hour it travels 10. In the second hour it travels 20. In the third hour it travels 30. So how will our graph look like? We'll see. So in case of uniform acceleration, that is increasing the speed uniformly. So our graph will be like what? So during my first hour it moves 10. So in my second hour it moves 20. During my third hour it moves 30. So my graph will be a straight line inclined to our time axis. So here I need to find, for example, we told that area under the graph gives the displacement, right? So for example, we need to, this is time, this is t2 and this is t1. Okay, and this is our what? This is our initial velocity u, and this is our final velocity v. So we need to find the displacement traveled from the time t1 to t2. So this we need to find the displacement travel under this law. That is, our area will be this, right? We need to find this area. How will find? See, this is our graph, and now we'll make this a triangle. Okay, we'll draw a line which is parallel to the time axis. Now this is what? A right angle triangle. Okay, so now you know how to find this area, right? This is a triangle, means half BH. Half, this is the B and this is the H. Okay, so we can find this area. And how to find this area? Length into breadth. You know this distance. How much it will be? 20. Which will be equal to this distance, and this distance will be equal. So this into this time will get this area, and triangle, how much will get? Half BH. We know how much is this? Parallel to the y-axis, and this one is parallel to the x-axis. So we can easily find. Okay. So the area under a velocity time graph will give the displacement. Okay. So this kind of graph interprets the uniform acceleration of an object. Okay. That is, object moving with uniform acceleration. Okay, so how we'll find the displacement area? This is our area to be found. First we find this area plus this area. Okay, so now how will be my graph if my object is decreasing the speed uniformly? For example, my object is decreasing the speed. So my speed will be in 30, and now it is decreasing uniformly, and the next hour it will be 20, and the next hour it will be 10, and then last hour it will come to rest. Okay, so how my graph will be? My graph will be like this. Okay, so this will be the graph of an object decreasing the speed uniformly. The velocity time graph. Okay, velocity time graph of an object decreasing the speed uniformly will be like this. it will come down. Okay. So what is the graph of velocity time graph of an object that is moving non-uniformly with a velocity which is non-uniform? So how much it will be? So first it will come to 10, then it will again decrease to 5, then again it will increase, then again decrease, increase, like that my graph will be. Okay, this is the velocity time graph, VT graph of an object moving in non-uniform rate. Non-uniform velocity. What is this? This is an object moving with what? With decreasing acceleration. Okay, decreasing acceleration, but uniformly. Okay, so these are our velocity time graph. See, this is the velocity time graph of an object with uniform velocity. It will be a straight line. This height will not change. A straight line parallel to the time axis. Then the object is moving with uniform velocity. And now if our object is moving with what? Uniform, it's increasing the speed. Okay, increasing the speed means what? Acceleration. So with increasing speed, that is in a uniform rate. Object moving with uniform acceleration, our graph will, velocity VT graph will be a line inclined to the time axis. Okay, and the area under this this slope will give what? Displacement. And this is the VT graph of a body decreasing the acceleration uniformly. Decreasing the acceleration. Okay, so it comes from 30 km/h to 0. So it will be like this. So what will be the VT graph of an object with non-uniform velocity? So this will be like this.